up there. I didn't press the go live button, but I'm picking up basically where I was before. Basically, I had a failing test here. I'm just a few minutes in. I've been streaming for 9 minutes, and all I found was that I had a failing test previously, and at the end of the last show, where this was stepping was failing, and the answer was that there was only 32 characters of memory, and I was jumping to I was moving the program counter to position 256. So so my change is this. I've added this initial memory size and changed it from 32 to that number. It was 32 because I was using the J REPL to interact with this thing, and so the entire memory was just one long string of 32 characters. So now we're going to make it a whole kilobyte. Whole kilobyte of RAM. Crazy. But that's good enough, I think. So I'm gonna go ahead and commit that. I was in the middle of typing something. Let's say add one. So jlang add 1 kilobyte of RAM. This repo has multiple implementations of the virtual machine. So now we've got. So I just refer to it. Talking about what direction, what implementation I'm using. Okay, and then also what I did on camera while I was talking to nothing was this, and I revert this now to what's on disk, and we have this, and basically I'm not sure why that didn't merge right. I thought that was in when I checked in. And let's say GD cached. Oh, that was the merge. Right. So I had this thing called I previously had this thing called the character handler, and that was a register of 32 things that were not part of RAM, and now they are going to be part of RAM. Maybe they shouldn't be. Maybe it makes sense for them to be that, but when we talk about when we get a value, then we're when we fetch a value, then we're going to get out of there for the first 250. Yeah, when we reach into basically the first 256 bytes of memory, we address them as if they're part of RAM, but they're actually part of the CPU, and that matters because there could be multiple CPUs sharing the same RAM. I haven't gotten that far. I haven't ever done that, but that's the intent. So maybe it actually makes sense for them to be in a separate thing, and I shouldn't get rid of this. Yeah, we'll see. Okay. Meanwhile, but for now, we're just gonna. I don't know what I'm gonna do yet. I'm gonna get the test passing in. As long as the test passes, it doesn't matter how it's implemented internally. All right, so basically all that's in this change is that I just did was I'm changing the letter C to the letter H, and that frees up the return stack to now become the control or the call stack. So if we do that through less-r, color equals 1 always. Now we can page through, see what the changes are, but they're all just that thing, that change. Oh, CGIT and CSET cget and cset should be hget and hset. Query replace cget should be hget. Query replace cset should be hset. I don't know what H stands for. I just picked H's for the or handler. I guess handler. Maybe that's a good name. Otherwise, I'd use the word dictionary, but D is so handler might actually be a good. Otherwise, R would be a good name. Oh, actually, R would be a good name. Maybe that's a better name for register. Registers. And then X, Y, and Z are not registers. they're gonna disappear. And instead, we'll just direct. We'll edit directly this H thing. Yeah, I'm gonna go ahead and do that. So query replace C. So now hset should be rset, and query replace hget should be rget, and then there were some things that were called like CD. Now instead of C for R, we can say R. So I actually swapped. I completely reversed the names of those. DR is now DC, DC, and vice versa. So these don't have to be old anymore. And in fact, this might be part of the microcode now. Looks a little wrong. Why is C? Why would it talk about the control? So this should be CPOP, right? CPOP. I don't want to change that because maybe I'm confused about what this used to be. Is this wrong? Should this be all register? Shouldn't. I'm not sure. Shouldn't register. The J mode for Emacs has some bug here. Oh, okay. Let's see what that was before. That's my problem. I don't want cache. Oh. Oh, I screwed that up, didn't I? No, do not edit the buffer. Dang it. Yes. Really edit the buffer. Save it to disk. Yes. Yes. I probably screwed something up. What did I do in here? I changed this C to H, right? And now I'm trying to change it again to R. H get should be R get, right? And now we want to change the query replace the changed R. Now we changed to H. Now we're changing it to R. So capital H should be R. That's stupid. I screwed this up. No. Oh, I think that was one. I don't know how to go backwards. No. Yep. No. Yes. Yes. No. Yes. So now Chev should really be RGEV, maybe. I don't know. Registry eval. GCH. CH is okay. Character, because yeah. You know what? That last one actually is okay. Chev is okay. Because it is a control character. It is a character at that point that we're evaluating that character. Right. Right. So basically, there's an opcode that should allow you to immediately invoke that operation. I actually don't have that in the debugger. I have something that puts the character on the stack. So if you say backtick, it puts the address on the stack. But if you say caret and like C, then it should invoke whatever it should immediately invoke whatever the function is. You know, basically, the C register acts like a dictionary for something, and you will invoke it. I'm rambling. So what have I done here? I've changed character handlers. I just want to call them registers, not. This is what we call RD. That's what the problem is. RD. That's what it's doing. So it's given a number, get it, and put it on the stack. Yes, that's right. Data stack to register. Right. So you have a number, a register number, say DR, and it puts it in there. This is not a standard opcode, but maybe it should be. Or I guess it should be microcode, right? I have to think about that because right, because in the Pascal version, it's written so there's only one implementation of the VM, and so of the CPU. So you only have one CPU, so it only has one set of registers, and it makes sense for them to be in memory. But probably they shouldn't be in memory. They should be independent of the CPU. And if you do that, requires extra opcodes. The intent, okay, I'll think about this. This is a design issue I wasn't planning to run into today, but I'm glad I did. So, let's just, so I think I'm happy with this. Let's gab4.ijs, jlang bring names in line with spec. So this is, I've made many versions of this over the years. So this is now final version. Okay, so this should have 26 test passing. Yes, it does. Okay. Okay. I think this is the one that I just did. This is this. I can drop it, and I work on a simple memory manager. That's old school. Let's see what we have in there. Yeah, that's completely weird. I will keep that around for later. I probably should deal with it, but so just I bring names in line with the spec and add 1 kilobyte. That's good. Okay, so that was so the second one was a refactoring after getting this test to pass. The test continued to pass, so everything is good. Now memory read. So IO mem read, show mem. So given an address, y, we're going to say m, so d of m, m from the virtual machine. We have memory is virtual machine. The virtual machine's memory, the mem of the virtual memory of the virtual machine. And J, can you say, so if we say A, that's the alphabet, those are all the bytes. And if we say 65, I want to get a range from here, right? And if we say 65 plus I26, right? 24, right? Oh, yeah, it is 26. That's the alphabet. So I want to say, given, y equals 65 here, we can just say m is the alphabet. Just treat this array as that. So I want to say y, that's it, and then I want to say 16 because we're going to get 16 of these things, and then we're going to for each one of those we're going to say a I. Right, so we're converting them to, we're actually using the source as the lookup table, so an identity here, but and then hex from decimal each, hex from decimal 1, that should give me this. What happens if it's too small? If I say like 32, if I say like 5, right? Oh, perfect, I get zeros. And then I say 2 upper, and then can add a space at the end of each one, and then concatenate them. And then when we do that to the memory of the virtual machine, rather than the alphabet, we should get this. And then at some point we will replace, yeah, that's good. Then we will replace, that's beautiful. That's some, sorry, that's just, that's a nice demonstration of J. Because compare that to the Pascal version. It's probably clearer in the Pascal version, but look how much code I had to write. I do have to do the, okay, this is not the same. This is not just dumping hex, so this is actually dumping, it's doing a more complicated thing than just doing the hex from decimal. So we'll it's disassembling things, looking at things in the table and so on. So, this is not apples to apples. We're gonna have to replace this H from D. For example, 0, 0 will be, let's say, ASM string equals. So given a byte, U8 ASM. U82 ASM. Byte ASM. How about decode? So we'll put a comment. Decode byte into assembly, into B4 assembly. And we'll just do this part. Decode. So that's this right here. Joining part. So you could do a case again. So I don't think you have ranges. So if y equals 0, do ... Nah. Else if we say less than or equals, or so we say greater than or equal to 1 and less than or equal to 1f, which is actually like this, so 16b 1f, base 16 1f, that's hex. Do, I'm porting this line right here. I'll even put it in like, even though it's just number 1, b 01 1f, do this is the same thing. A minus. No, we actually need order plus. Okay, so do Right, because we're converting from the. I don't think this is even right. So we're converting from the control character to the thing. So we're going to say ord plus a, so char. Actually, we just do this. So we can pull right out of that dictionary. So this is binding that static constant dictionary of all the ASCII characters to the lookup, the extraction verb. Basically, now it becomes a one one argument function, a monad that takes a byte and gives you the character back. Which is actually I'm saving one character here, but I'm having to type it here. But right, so this gives you the caret notation for control characters. Else if and again we're going to say 16b01. Now we're going to change that to 80. So these are the Unicode characters, or the bytes that cannot start a Unicode or a UTF-8 sequence. So these are going to be do I have an op table? I have ops. So ops of VM, I guess those are the ops. So I want to disassemble them. So if we say ops VM and we have like the number like 80, so 880, which is 16b 80 is 128. So number 120, yeah, of course, 128. We'll say y equals 128. That's not a valid thing. And now we're going to make this function that says we're gonna take so it's really just this y minus 16b80. And it's LB, and then we'll yeah. So this is the op table. Okay, so it's actually because I had it in a table, it was much easier in Pascal, but that table took some time to generate. And then yeah, so then actually B0 or A0 and B, all the ones that start with A and B in hexadecimal are also in that area. They're meant for hardware, so they don't really have a code. So we're going to say else, and this is where I'm worrying that J does not let me do this, but else we're going to say this. All right, so let's see how the disassembler works. How well it works. What's wrong with that? Show mem Did not. Oh, because I called it show. Showman. To be cute and take fewer letters. So this should be called memstring. And then show mem equals memstring echo and memstring. What? Because I have the number 5 hard-coded here instead of the number y. Part of the problem. That shouldn't be the so okay. I think it's taking this. Let's see. Show mem address. So what is adder? Decimal from hex. Let's break into J. Say adder of the head of the token probably. So we say here I'm getting adder of right here 0 1 0 0. That should give me some. Okay, that gave me one number. Actually, doesn't matter. Adder would have been. No, that didn't actually matter, but that's okay. And then after adder, we say show mem. So show mem 6. All right, so something happened here. So memster adder 256 memster 256 plus I16, right, from M to VM. It's all empty. Oh. And then if we say AI, oh, they're all zeros. Okay, so that is correct. Okay, so then what is decode 1000? This one's interesting. It's not, it's D0. Decode at rank 0, that's why. I want to decode each and every byte. Why isn't it? Just do 0 0 0 again. Yeah, that's what it's. All right, so now this should work. What was the bug? The bug was just the rank was wrong. That's not what I want. This. Tests are working, but when I try to put memory in, then put mem fails because put mem is this. Why is it a syntax error though? I'm not sure why this error gets raised. Oh, I see. Because this failed, and then now the now J is back in the we're back in the J REPL, and it's trying to interpret that as J. Interesting. Okay, so that's no good. That's a consequence I hadn't anticipated of the way that I do this latent expression thing, this do next thing. Yeah, because like normally reading from the that's interesting. Like it's all right. Well, I'll ignore this for now. It's not important right now. This is what's important. So this is because putmem is defined as this character right here, which is called cap, and basically it's a special thing that you put on the left side of a fork to make it. It's a way of doing composition another way of doing composition within a train. But when you call it without a train, if you just call this, it raises an error. So domain error putmem. So the idea is that putmem is going to take this is actually encode, right? Encode bytes as B4 assembly. And then this should be encode. Now we want to decode, which would be assemble. Right, so decode the assembly lane. But in this case, right, so we have this string right here. Where are we calling it? Putmem. Mem line. So putmem and put. We can cut off that one character. String with address and address bytes to decode. So decode string with and into okay, so alright, so we'll have a string like this up here. It does not matter if this is here or not. For now, I'm going to say decimal from hex. So split string with this. Yeah, split string. And then decimal from hex each every. And this will have to be decode at some point. Let's go ahead and call it decode. So decode is going to be decimal from hex for now, temporarily. Code equals decimal from hex, and then That will give us a list of bytes. And then actually we could say bytes. We could say adder and bytes, and then equal to, and we could do it like this. So take the head and the tail and put them, and then adder is this and bytes is this. This is using multiple assignment to that. Adder and bytes. Oops. Adder and bytes. To given that, okay. And then now we have adder. You can say adder plus I length of bytes. Those are the addresses into which we will put the bytes. But we want to actually look up the bytes in the ASCII table. So we want to say bytes from the ASCII table, and then we're going to put them into m.vm. And I'm just in a plain old JREPL with no, I don't know what's happening. Yeah, so I just ran J. Okay, so anyway, put these into memory, and then that's it. We got a length error here. Why do we get a length error? Y plus I16 m. First of all, I didn't. This isn't an assignment. This should be m.vm is equal to that. Why am I getting a length error? Oh, ma'am. Wait, hang on a second. "27 tests pass," and do I have 28 tests pass? No. If this is a length error, it means y is not a scalar. Y ought to be a scalar here. So if we go ahead and paste this in. What's going on? How do I get a length error there? JDB? How do you invoke the debugger? dbr1. That's what should happen. Adder at 0, 1, 0. Why is that? Adder. Oh, I did an assignment to the word adder right here. Yes, and I used the global assignment. This is the right way to do it. Okay. That was my problem. All right, that's easy. So I replaced this name adder somewhere with so now this test will pass. 28 test pass, and so now the domain error in code. Why? Okay, well, that should not be a plus sign. That should be oh, okay. So hang on. So first of all, this is a comma, but then also this is wrong. So this should be less than, right? Okay, so it's in this range. Now we're getting index error in code. What? db? 16. If it's in this range, 80 through 9f, do that. Problem. Think here. What's going on? In this range, if we're in this range, then factor from here and pull it in this. I see the problem. The problem is that this is 32 opcodes, but we don't have 32 opcodes. But why is it? Is this the 128? That is the number 128, but why is it? Why doesn't it print it out the way I? 128, right? Yeah, okay. It is talking about that number inside the encode function. Yeah, right. Y minus. I see what's happening. I'm getting a number that is bigger than. Where do we put it? We put LB into memory. It's because decode is not correct. If H. So if Y, so we say if Y box is an element, so MVM, no, we want ops of VM. Then we want Y is, say, LB, right? That's the one we're actually working on. So we're going to say, is the box of Y an element of this? Yes. But we actually want the index. Backwards. So we save that as IX, and that if that is greater than length of ops VM, really we should just do this. So nops, num ops equals length of ops VM. How about last op? Last op equals 16b80 plus the length of ops from VM, and then last op. Then we do this. We don't need a last op. Then we'll do that. What happened? I have a control error, is that right? So basically, I've started something and didn't finish it. Do else if, do else if, do else, and oh, I started the decode and I didn't finish it. I lost track that I was in the middle of writing decode. If did I confuse myself and go fix a completely different bug that was not actually happening? I'm not sure. I mean, this was a bug, but did it have anything? Okay. I think I went off on a side project in the middle of fixing this, of adding this line here. All right. So if this is what I was trying to say. here we actually do want num bytes. So num and num have an op count is equal to the length of ops VM. And if op count is greater than so basically we're finding the index, right? So if op count is greater than the index, is this, then if it's equal, it's going to be greater than or equal to. If it's equal to, then it means that we, you know, if you say hello and you look for the position of H in there, you're going to get 0. But if you look for the E, you're going to get 1. But if you look for the Q, you're going to get 5. And if you look for the V, you're going to get 5, right? Because it's not in there. If you look for the O, you're going to get 4. This is slot 4, and anything else comes out 5. It's a little weird of a way to give you the thing. So basically, if it's equal to the length, then it means you haven't found it. So this is a way of saying, is it in the list, while also capturing the index. If it's in the list, I don't really need this. Just inline this. Sorry, I'm a little tired. You know, I was complaining earlier about not remembering all my J, but I really do like this language, even if I don't understand everything. You know, take some time to reload it into my head. I'm not experiencing that. So, if that's the case, if it is a op, then we're going to say, what do we want to do? If it is an op, then we're going to get, we're going to return, it. Else, x from decimal. No, we want then we want 16B80 IX. And wherever we say 16B80, we should say first op, or like op index, op IDX. How about op byte, op code? Yeah, so op code is 16B80 and the start of op code in the number of first op code. Number first op code. Byte code for first. Byte code of first internal instruction. Like all the ASCII characters are something. And then the delete, which is character 127, is the I'm reserving that for extended operation, like a prefix for extended operation. Then 80 128 is the start of, we'll say opcode here. And maybe it was out here. Last opcode plus. And so make that last op. And we'll say opcode. Whereas these are the control characters. Maybe I should have some last top code and op last. I'm gonna call op last. Actually, we want to upper here and remove it here. And now, so we actually did get the expected output. I think this might possibly be correct. That doesn't seem right. Doesn't seem you would get 2C from that. Decimal from hex. AB is this number. Make it negative and then say hex from decimal. Well, it's possible the load byte doesn't work the way it should. We get assign byte onto the stack. That is correct. Get that the correct pick? Not sure. Well, I'm not sure that's the correct. It's 127. You get 7 after. That's correct. And if it's greater than 127, so if we get 128, instead of 80, we should get negative. I'm trying to think about how binary numbers work. Instead of so 128 in binary looks like this. It's like it's a 1 followed by a bunch of zeros. And if we have 127, it looks like this. And if we so make it an 8-bit number. This is 7-bit. Yes, make it an 8-bit number. We put that 0 in front of it. Then the idea is that if it's negative, I don't. So negative number. Negative 127 doesn't seem right. We're actually going to tell it to convert to to getting, yeah, come on. Where's the syntax error? Yes. Okay, that's negative 1. Right, that's what I expect. 127. Sorry, 127. Okay, so what is, I have negative 127. This is saying, I'm looking at this right here. It's saying, take the number negative 127. 127 minus negative 127. So basically, take the number, make it negative, so 128, flip it around, 154. What the heck am I doing? What am I? I don't know where this came from, where this notion came from. Because like once we have this, right? Now if we encode that as binary, one, that's 8 bytes. Right, because we can go all the way to negative 128. Right? I think 171. So if we actually have the number 171, this is nonsense. Just okay. You have the number negative 128, and that ought to be, when we do that, right? It should look like that. Negative 128 is 0, and then negative 127 is 1. Negative 126 is same as 2, but with a bit set. Okay. So how do we get to those numbers from 128? What wrong? This seems wrong. So if we're given this number, which is not, which is signed now. So now we get to this. This is 128. Given the number 128, 128 is bigger than the number 7. So we want to Go from 128 to negative 127. And we're saying 128, passing it this, and we're saying negative 127 minus reverse of is negative 1. Yeah, it's completely wrong. Be like this. It should be 1, negative 1 right here. This is what it should be. Negative 1. Is this a but we don't need this. We can write it like this. We can say negative minus negative 1. Which is negative plus 1, right? Wait. Yeah, it's that. So this is a plus 1 operator and this. Right, so that should do it, and then that should fix it. So I'd implemented that, and I just did a stupid implementation. Negative AA. Now we're talking about, it's not negative AA. So where's the negative? Not negative Y. I'm trying to think, because there's two cases here. Like it's entirely possible to have this number on your stack. A negative AA because it's a 32-bit number. But when it's a byte, wait, it doesn't have to be signed. Is that the idea? Is that LB should be bgit? That's the underlying issue. Unsigned. Yes. Okay. So we went from 28 tests. Yeah. So we passed that test. All right. Here. WBVM. What's going on here? High error of WBVM. It looks to me like I did not implement that function. All right, so let's oops. All right. So show memory, and then gdb4.ijs. Oops. So that one, what we did was lb jlang b is now unsigned. Now loads. I played with the idea of an operation that was called ls that would load a signed. Like load short. Do I want that? Maybe I do want that load short. I don't know. I think I don't need load short, but it would be called ls instead of lb. LB is load a byte, it's unsigned. That's correct. But we still have s. So bget is unsigned. sget, and we still use sget. Should be using sget for a hop. So sget. Where's hop? Hop should be using sget. That's almost certainly a bug. Seems like I had those backwards. Because hops can be backwards, whereas just load a byte, loading it as a number, and then if I wanted to convert it to signed byte like that, I could do that operation that I just did. Test whether it's greater than 128. So. Okay. So maybe that's a potential extent. Oh, I'm getting tired. Sorry. 12:30 here in the morning. Backward hop. So I wrote an assembler in this, but I don't think I've ever actually run it. So I think this probably just has not been tested very well. 29. I think we have 37 tests. Anyway, now what's wrong with WBVM? Oh, that I haven't implemented write byte. Is there a B set? Bget. B set, we have a B put. So WB is B put. It's the same as these, but it's so read byte is not mget, but bget, and write byte not mset, but bput. I think that's right. Byte b copy hints, yeah. Copy from U8. I expect that to pass. bput should be set. This is exactly the same. What's different? The bput and mset are exactly the same, except for this number. Oh, I see. Except for this. There we go. So this is being passed in incorrectly. Okay, so bput write byte x, so b to address a. So here this is evaluated first, but no, it's x. It should be x. This seems wrong too, because here we're converting it. So here's an address in x. Now I'm confusing myself. So hello, and then you say what you want to write. No, the address is here, right? So 2, and we put a x 2 here. Okay, so the x is the thing to write. Store u8 x as u8 at y. -1 is 255. Right. Yeah, that's fine. Okay, but now m. So okay, so y. I think these might be backwards. Given a byte, I think it's like this. Why is there a syntax error there? No, domain error on B. No, it's not that. It's dput and also echo at this, right? Come on. Why doesn't this echo? Oh. Something's wrong here. These are in the wrong order. Yeah, this is completely wrong. I was trying to modify the code to. So B put is just completely wrong, right? Because you wouldn't use this. You would tell it to put it at address Y. We want X over here and then Y at this point, right? And then really this would be the same thing. I don't think this works at all. I think I wrote this and as like a spec, right? Yeah, yeah. Wait, I was waiting for the test to run. They're not. This is still going to output. Okay. Happening there because it's backwards. WB because I saw the tilde in there. Right byte. Now X is the thing to write. 256 is the address. So I did have it. Store X at Y. Y is the address. Is X is the why is it backwards? Why am I confusing myself? M a VM at 256 should be the number. Not 1. B put VM. What am I doing wrong? a VM, the memory of the VM. And that should say, yeah, AB. That's what I'm expecting. Why isn't it? Okay, so if we say 66 dput VM, 67 dput VM, and then 7, right? And then now we say WB VM. What I'm expecting. But we're assigning to M. Whoa! Oh, because I screwed it up. I didn't do the thing. Okay, so it was a no op. Okay, so I had an extra copy of WB underneath there. So now when I do this, I would expect it to. Data stack of the VM is I gotta. So put the VM 67 and dput VM 67 and then 7. And then WB VM, and that should pop those things off the stack, and then you get ABC. That's it. Okay, so now this works. Writing to RAM work. And here we can see what the problem is. We're not writing little endian and big endian, so mput mset Can you say, I don't think you can say -5, right? Oh, you can. We could put that either way. Go ahead and do I of -4. Right. So it's adding, but there's no, yeah. Okay, so that got that. So that fixed this issue right here with the numbers coming in backwards and whatever. And then RX. I'm almost done with this. I'm going to stay up and do it. It's almost 1 o'clock here, but read a byte from there and increment. So that's an unrecognized token RX. It's not XR, it's RX. Read X, read Y, and write Z. I'll get a different error where it's, yeah, those don't exist. I just saw something very similar to that. Okay, so this is old. What we really want is RX. Looks like it's going to be similar to that, though. This is reading a byte from Y. And this is... so we're going to... We're going to get but we want this 88. I have a function that does this, right? Given that ord is this. Then reg x is going to be rega of. No. Right. Right. How about X register? Y register. And then Z register. And then RX is going to be we're going to say like the address is, I'm going to look at the Pascal version. Before no, I want UB4.pass. The actual logic of it. Yeah, I want this. UB4IJS. So we're going to say, so RX is this code right here. I'm going to say A is going to be, some temporary value is going to be, or T, you know, so some temporary value is going to be read val of A, and read val here is called what? mget yreg. And then mget t, I'm going to deput mget t. And then set, or this maybe should be called input on bput. I probably should call it whatever. And then mset here. So store x at y. But store x. So x is going to be, the new value is t plus 4 for and this has to be inference. So we could put this all on one line, t, and get yreg, and then this goes here and this goes here. I don't want to call it yreg when I'm talking about xreg. That would be read y, and then we'll do x. This should be xreg, and then this should be xreg. All right, so temporary value is reading from the X register. Then from that temporary value, that's a pointer, so let's read from that pointer, put it onto the stack. I'm going this way. And then go back to the X register again, set that to t plus increment. And then to write z, so this is, this is for doing array operations. So you read X, you read Y, then you add them or whatever. You have two values on the stack, and then so you want to depop m set. At zreg. That's it. "36 tests passed. What's missing?" Right? Z fails. So reading worked. Domain error M set. Oh, M set is a dyad. You have to actually invoke. You can't. It wouldn't be like this. It would say depop of this to actually do that. And I think all 37 tests passed. Okay. I don't know how much of that was comprehensible. It made sense to me. This is not the greatest J code right here. Clean this up definitely a little bit, but I'm gonna call it a night. So gdb4.ijs. jlang dot b4ijs pass pass 37 tests. Pass all 37. Okay, Yeah, so the next work to be done here, I have a little bit of work on the Godot version because I swapped the order of arguments in the test, and then I have to go back and update the Godot version. Um, and then I need to extend the test because there's probably some things. There are numerous opcodes that are not under test yet that I need to. That I think are working for the Godot and Pascal versions, or at least for the Pascal version. And maybe I just haven't implemented them on the others. But they have to do with jumping and hopping and that kind of thing. So the control flow ops are basically the ones that are missing. And I think they're mostly working for J, but I don't know for sure. There's a lot of edge cases for each one of the ops. Like, you know, what happens if you multiply and you overflow? Well, maybe J will probably just let you have a bigger number. That's not right for this architecture. So we have to do overflows and that. What happens if you shift too far and that kind of make sure negative shift works. And then there's an assembler that was written against this copy. I don't think I ever ran that assembler. I wrote a Python program that, like, I thought through it, but I wrote it as I never tried to actually assemble anything with it. Never tried to assemble itself with it, as far as I can recall. It was just like I was just writing what I believed to be the case and like making sure it worked, but never actually ran it. Like an intellectual exercise. So I'm not entirely sure that it worked, but once I get that working, I should be able to run the BIOS on all three versions of the system. Right now, it only runs on the Pascal version. And then, if the assembler was running on this one, it's almost certainly broken now after all the changes I've made. So it needs to be updated and then tested. And then I should be able to run the assembler on all three. So I don't, you know, it's a self-hosting assembler. So even though there's an assembler written in all three host languages so far, the goal is to get an assembler written in V4, and then it's self-hosting. And so now you write, you can leverage the assembler as you're going along, right? You could just implement you could use another copy of V4 to help you bootstrap a new copy of V4. And in fact, at some point, what I'm hoping is that you'll. So once I get all that working, then like everything I've written is all in sync with the current spec and ready to go. And then the next thing I want to do is implement, or I've written some parser combinators in J. I want to port them to the virtual machine. And then I'm going to have a little template engine. And so you've got a parser and a template engine and a tree builder. And so you'll be able to use the virtual machine, build up an AST of something you want to generate, and then use the template engine, turn that AST into code. And then the idea is there'll be a little program that will prompt you for, like, how do you write an empty program in your language, in your host language? How do you add two numbers, or how, you know, what's the syntax for doing this and this and this? And you fill in these little templates from an interview, and it will try and pass the test for you. It'll try and generate all the code you need to implement the whole system in your language. And so it'll be something that, yeah, I don't know. It's almost like a meta compiler or a meta transpiler, maybe. That's my hope. That's something way down the line. But I also, you know, I'm planning to make the spec open source, and it is open source, but it'll be better explained, and there'll be documentation, and there'll be website and that kind of course I'm building. And then the course is like how to build this thing from scratch for yourself. So this is going to be ultra portable. I hope to see many people going through this course building this virtual machine. A much, you know, like this code like already has stuff on the screen that doesn't need to be there. But because there's too much junk in there. But like make this small virtual machine. Teach people like how it works, what the idea is. Implement your own. Here's the test, and it'll be a fun experience for you. You'll learn something about uh, low level programming in virtual machines. And then now I've got this virtual machine that is ultra portable and has all these implementations that many people might share, and they could be in different languages. And now you've got something that you can use to put a library that runs anywhere, from your little handcrafted code here. And I don't know. To me, that this is going to be a neat thing. But I'll save the sales pitch for today. But even just having the parsing library ready to go. So now you build this virtual machine and you get the assembler and all that stuff for free. Yeah, that's the hope. And there's a lot of stuff I want to do. I've been thinking about this for a long. But I will save, again, like I said, I'll save the sales pitch for when I'm ready, and stay tuned, because interesting things are going to be coming out of this, if you found this at all interesting. All right, well, thank you for watching. I guess, did I check this in? If not, I will check it in offline. Yeah, I did. And I will, I don't know what the next video will be, but I'll be popping up work on this general theme, whether it's in J or Godot or Pascal or some new thing, or probably doing some work in the assembly language itself. And yeah, stay tuned if you're interested. Thanks for watching.